Hi guys, in this tutorial I'm going to solve the question number 3, paper 41, June 2013. In question number 3, the top of a cliff is 40 meters above the level of the sea. A man in a boat close to the bottom of the cliff is in difficulty and fires a distress signal vertically up from sea level. Find the speed of projection of the signal given that it reaches a height of 5 meters above the top of the cliff. First, this is the cliff. Its height is 40, and we start to project from the ground or from the sea level with initial velocity not given to reach 5 meters above the cliff. This means reach to the maximum height, so V is equal to 0. So the initial velocity is not given, he asked to find. And V is equal to 0, S is equal to 45, and A is equal to -10. When the particle start writing V squared equals U squared plus 2AS, the final velocity is 0, initial velocity is U squared plus 2, acceleration is -10, and the displacement is 45. So you can find the value of U. 2 times 10 times 45. 2 times 10 times 45 by taking the square root. So the answer will be, will be 900. So U is equal to 30 meters per second. This is the velocity of projection down to up. In part 2, find the length of the time which the signal is above level of the top. So to get the length of this time, we can find the time when it is exactly 40 meters. You will get 2 timing. When the particle move up and when the particle move down, subtract them to get the duration time in between. This is the first method. So if we use exactly S is equal to 40 and initial velocity is equal to 30, acceleration is equal to -10. By using S is equal UT plus half of AT squared. S is 40, 30 times T plus half of -10 times T squared. Simplify this equation will be 5T squared minus 30T plus 40 is equal to 0. You can divide it by 5, will be T squared divided by 5. Divided by 5 is 8. By using factorization method, you can find the values of T. T times T, 2 times 4. So the first time is 2 and the second time is 4. The first time of 2, this means when it is moving up, this time is 2, move down, this time is 4. So will be above 40. To get this duration time, we'll subtract. So the length of time will be 4 minus 2 is equal to 2 seconds. This is part 2. You can solve this question by another way. How? If we start to get the final velocity in it is exactly 40, if you try to get the final velocity when the displacement is 40, we have already initial velocity 30, displacement is 40, acceleration is -10. You can find the final velocity. Use this final velocity as initial velocity in this part. You will get the duration time when V is equal to 0. Then multiply this time by 2, you will get it the same answer. In part 3, the man fires another distress signal vertically up from the sea level. This signal is above the level of the top of the cliff for a route of 17 seconds. Find the speed of the projection of the second signal. Again, this is the cliff. It's 40. But now it's given the particle move up and back to this point. It's given route 17 seconds. This is the duration time above the level F40. Find the speed of the projection of the second signal. Ask to get the initial velocity. So you can find this time divided by 2. So the time taken to move in this part only will be root 17 divided by 2. So the final velocity here is 0. You can find when initial velocity is not given, acceleration is -10, and displacement is equal to 40. Now look at this part. The initial velocity in this part is not given, but the final velocity given, the time given, and the acceleration given, -10. So you can find the initial velocity here and use it final velocity for this part. If we try to write the equation of V equals U plus AT, the final velocity is 0, initial velocity is not given, acceleration is -10, time is root 17 divided by 2. You can find the initial velocity. Will be 5 root 17, 5 root 17. I will use it now as a final velocity in this part. A final velocity in this part is 5 root 17. If we try now to write V squared is equal U squared plus 2AS, the final velocity is 5 root 17 squared is equal to initial velocity plus 2 times -10 times the displacement, which is 40. You can find the velocity in this case. U squared is equal to 5 root 17 squared plus 20 times 40. So the answer 1225 by taking square root. So you will get initial velocity is 35. That's it. We ask in part C, find the speed of the projection of the second signal. Thank you.